Today we're going to look at the discont option for Maple's plot command, which is a very useful option when you're trying to make nice looking graphs in Maple for functions that have discontinuities. So let's start with a function that has a really obvious sort of discontinuity, a function that has a vertical asymptote. So let's use the function g of x. So g colon equals maps x to, we're going to go with 1 over x plus 1, all of that minus 1. You may recognize that as the function 1 over x shifted left and down by 1. So it'll have a vertical asymptote at -1 and a horizontal asymptote also at -1. So let's see what happens when we graph g. And I'm just going to do a basic plot and not worry about arguments for the moment and see what comes out. Okay, so what you see here is we have the graphs of g of x. And those nice curvy lines are actually the graph of g of x. And then you've got that line up through -1 where the asymptote is. And what's going on there is that Maple is not looking for discontinuities in the function, so it ends up evaluating points very, very close to the point of discontinuity and then connecting them. So the effect is that the vertical asymptote is actually drawn in as part of the graph. Notice that the horizontal asymptote is not shown. So what if I want to get rid of that line down the middle of the graph? That is something I can do with the discont option in plot. And what discont does is it tells Maple to look for discontinuities in the function, and then it splits the domain of the function that it's graphing into regions that don't include the discontinuity, so you don't get that strange connecting bar up the middle. So we want to plot g of x, and discont takes true or false as its argument. So we plot g of x, but now we tell it to look for discontinuities with discont equals true. And see, there we have our nice graph of our transformation of the function 1 over x without the goofy looking line down the middle. Another thing that you can do with discont is use it to graph functions that don't have asymptotes, but they have a single discontinuity, a single undefined point in line with the rest of the graph, and you want to show that that point is not included. An example of this sort of function is we'll take h to be the function that takes x2, let's do x squared minus 1 over x minus 1. And you see that this function has a discontinuity when x is 1. However, if you factor it, you'll see that the factor x minus 1 appears in both the numerator and denominator, so it cancels. And the graph of this function actually just looks pretty much like the line x goes to x plus 1. So what happens if we graph this? It just looks like the line y equals x plus 1. It doesn't actually show the point of discontinuity. So we may try, okay, well, let's say plot h of x and say that it's discontinuous, so discont equals true. You see, that doesn't work either. Luckily, for this case, discont takes options. And we're going to do one. You can look and see what all the sub-options to discont are in Maple's help bar. But we're going to look at show removable. So we're going to say plot h of x. And we're going to say discont equals, and instead of just telling it true, we're going to pass it in square brackets the command show removable. And see, what this does is it shows our graph of h of x with a nice little open circle where the removable discontinuity is. And that's a couple of things that you can do with graphs of discontinuous functions using the discont option to the plot command.